Half a century ago, we took our first step on the surface of the moon. Today, there is renewed passion to explore for our next human endeavor. Mars, the red planet, further than any human has ever been. We face many challenges: remoteness, no livable atmosphere, high radiation, dust storms, and extremely low temperatures. Before any humans set foot on Mars, we must first design a protective shelter. We will protect our astronauts from radiation with a thick 3D printed shell structure using Martian regolith, which works great in compression but does not perform well under tension. To overcome this shortfall, we have chosen to construct the pressure-retaining parts of the habitat from lightweight, inflatable pods. They will be made out of high-precision engineered composites that are prefabricated on Earth. Their elliptoid geometry will be able to mitigate the pressure differences whilst optimizing spatial planning. To create the base on Mars, we will use a two-phase approach. In Phase 1, an ecosystem of 3D printing robots will arrive months in advance of any human explorer. They will construct the protective shield for the base by adopting a modular robotic swarm strategy, a plan that allows for redundancies and enhances the odds for success. Intelligent autonomous robots will have interchangeable roles, from battery storage to scout rovers, logistics to excavational, and even 3D printing units, all integrated with multiple cameras and sensors for navigation. They can reconfigure themselves for a multitude of purposes, ensuring prolonged usage beyond the initial build phases. The smallest configuration is the one-wheeled scout rover that uses ultrasonic scanning to analyze the Martian surface to determine the best regions for obtaining optimum regolith. The digger receives the location coordinates and then excavates the Martian soil. It then delivers the payload to the refining assemblies. Here, large chunks of Martian regolith can be processed down to a finer grain and then delivered to the melter robots in situ. They then use concentrated microwaves to melt the regolith and extrude through the 3D printing nozzle. The shell is autonomously 3D printed, layer by layer, over several months by the robotic system. In the next phase, the first astronauts arrive with the habitation units, equipment, and supplies. The robots now take on their second life roles to aid the next phase. They come together to make flexible mobile platforms that can carry the payload from the loading zone to the base. The convoy begins its journey across the Martian surface to the habitat site. The build commences with a connector module placed underneath the protective shield and readied for inflation. The module then unfolds and self-inflates into its final form. The habitation units are then placed into position and sequentially inflated to form the completed pressurized environments. The circular layout of the habitat ensures continuous accessibility of the habitat in the event of a catastrophic failure. Each connector module houses 3 integrated environmental control life support systems, delivering essential services like power, water, data, and oxygen to all the habitation units. A circular conduit delivers these services to multiple endpoints in each pod. The base will be remotely powered by 2 nuclear kilopower reactors in a solar farm, located a safe distance away from the base. In the next stage, the astronauts will construct and install a flat-pack, rail-based racking system capable of connecting to the distribution system, enabling spaces to reconfigure according to their spatial needs. This modular and radical design principle has been adopted for all the habitat pods, ensuring multi-use, reconfigurable environments. A Martian base should not just be a habitat. It is home for the astronauts. Each pod expresses its own identity, quality, and character. A highly functional design which places the human experience at the core. Spaces include a state-of-the-art research laboratory, a hydroponic greenhouse, a fully equipped workshop with digital fabrication facilities, the sleeping quarters with gym facilities, and immersive virtual reality platform. We believe that the key to success of human habitation on Mars is the health and well-being of its residents. Creating a place where work, life, and living combine holistically to ensure they feel connected to each other, to themselves, and somehow to their distant home.